Alright, so for this video, we're going to briefly go over logarithms and kind of explain the basis of what a logarithm is and kind of how to manipulate the equation so that we can get to understanding how to evaluate it. So how we read this is, since we did exponents the other day, today we're going to focus on exponents, but now build on logarithms. So we have a to the x equal to y. Since we have a to the x equal to y, we want to transfer that into a logarithm. So we're going to say that log of base a y is equal to x. So the words we're going to use is the logarithm of y with base a is equal to x, right? So let's kind of write some examples on the board and kind of go through some examples. All right, so right here, right now, we have two examples that we want to go over that are very basic. So we start with this equation right here. We start with a basic logarithm for both examples, and we want to turn it into this expression. Why do we want to turn it into that expression? Just because from a visual standpoint, it's a lot easier for us to understand exponents since we previously did it. So we want to turn it into an exponent, right? So we have 25 with log from base 5 is equal to y. Well, let's convert that. We will convert that to 5 to the y is equal to 25. Then from there, we want to just say what y is. Well, what number are we multiplying by 5, or what multiple of 5 are we getting that equals 25? Well, I know 5 squared is 25, so y in this case will be 2. So if I revert this back to my original equation, this would be 2 right here. So 25 with log base 5 is equal to 2. All right. Second example. So again, I want to rewrite this so that it makes sense to me, right? So I have 4 to the y is equal to 16, right? That's going to lead me to say what y actually is. In this case, 4 times 4 will give me 16. So y is 2. So I'll put y is equal to 2 here. So that means 16 with a log base 4 is equal to 2, right? So again, we want to convert everything back to exponent rules. Why? It's because that's what we understand so far since we did exponents the other day. So this is just a carryover and to understand how to do logarithms through exponents. So let's carry on to a different part, different aspect of this so we can deepen our understanding. All right, now let's look at delta math, and we're going to go through some examples of how to answer these questions. So again, we've already received this question. So we have 16 log of base 4, and we know that if we write this as 4 to the x is equal to 16, we know that 4 squared is equal to 16. So this answer should be 2. Right. So we're going to go over a couple of these so that, you'll get the understanding, the basis. And again, like I always say with delta math, you get it right or you get it wrong, it breaks it down for you, right? So let's go to the next problem. All right, next problem says 343 log base 7. So again, I want to write it in a way that I understand it. And I know I understand exponents, so I'm going to write this as 7 to the x is equal to 343. So again, all right, so now what I want to do is I just want to go to a calculator. So I have 343 base 7, right? So I know that 7 times 7 will give me 49. 49 times 7 will give me 343. So what that tells me is that I would have 7 to the third power is equal to 343. So that means this answer to this question would be 3. right? And so again, I'm gonna do a couple more until we feel like, it's very helpful and we got to understand it. So again, we're taking 625 log of 5, right? We seen 625 a couple times yesterday when we were doing exponent rules, right? Also in geometry, when you're dealing with Pythagorean theorem, you've seen 625 before. So we want to write this as exponent rule. Why? Because we understand exponents a lot easier. So I believe this is 5 to the 5th power. Let's go ahead and double check through our trusty old calculator. So instead of multiplying 5 times, I'm going to hit 5 to the 5th power. And so all I did was I selected this option here, X to the Y. That will give me that little funny looking box up in the corner, and get to type in, I could type in any number. So 5 to the 5th power is too large, right? So let's do 5 to the 3rd power. 5 to the 3rd power is 125. So 5 to the 4th is 625. So our answer here is 4, because we're saying that 5 to the 4th power is equal to 625. So that means the log of base 5 of 625 is equal to 4. So then go ahead, type in 4 as my answer, hit submit, and it's going to tell me that I'm correct. Another way to look at this and to do this is saying, hey, I understand I have log with base 5 or 625 log with base 5, and I want to say that that is equal to x, right? So now in order to find x, what I can say is that log of base 5, I know 5 to the 4th power, what is that equal to? Well, that's just equal to 4. How do I know? Because the natural or the equation for log is log of b to the bx is equal to x. So essentially all I'm doing is finding out what power that number is raised to by using the base. So if I use the base, my b, and I find out what power is raised to, then that is subsequently my answer. So if I find out what power is raised to, that is what my answer would be. If you got any questions, please let me know.